Okay, let's keep going and rocking and rolling. Activity 2.3. Looking at activity 2.3, we do have to do almost the exact same thing that we did in the previous activity. Going to give you all a moment to do the linear regression equation for this. I'm not going to do it with you by hand, but remember, you're going to input the table, then use the y1 tilde mx1 plus b. Write out your equation. Pause the video to give yourself this moment. After you pause this video, you should get this equation. Y equals negative 1.1x after rounding plus 42.3. Right here, I'm not going to really talk about the coefficient of determination just because I want to keep it in the Algebra 1 concept of just what we've been doing the past few years. The correlation coefficient, don't forget that's my R value. We're not looking at R squared, we're just looking at the R. If you did the table correct and you looked at the correlation coefficient, you should see that the correlation coefficient was negative 0.88. And if we interpret it, we know that it's going down, but is it a super strong? Is it a good strong? What kind of strength do you think this is? I think that it's still forming a pretty nice straight line, so I am going to say strong, negative. I'm not going to say super strong because it's not a perfect line. It is a good line, but it's not a perfect line. Does it seem appropriate to do the line of best fit? We can, but we want a super strong. We put a big butt, not the butt, you know, like the ugly butt. Just kidding. We can, but we prefer super strong. Definitely get this, graph it. I am actually going to take the time to graph this because this is all approximating, which could get a little bit of tedious if you're not patient. This is kind of difficult too, only because it's kind of curving, which is what we kind of don't like. So we can't really technically draw that best line fit because it is curving. It doesn't look like a beautiful straight line, okay? It's kind of curving like this. But it has to do with the intervals too, so I agree with our statement. We prefer super strong. Okay, it's only been 3 minutes, so I'm gonna go ahead and jump into 2.4 as well. Does correlation mean causation? What do you think causation means? That is a question that the statisticians are always trying to determine. Remember, causation is when something causes the other, while correlation is what we were just doing with our points and whether it's going positive relatedly or negative. Read these 3 true statements that Alonzo and Richard are given by their Algebra 1 teacher. She asked them to decide what the conclusions they can draw from the data. Do you agree with him? If so, why or why not? This is an independent practice portion, but just because I feel like doing this, we will do this together. The number of smartphones sold in the United States has increased every year since 2005. The number of flat screen televisions sold in the United States has also increased. Alonzo and Richard reached the conclusion that owning a cell phone causes a person to buy a flat screen TV. What do we think? Is this a causation or correlation? Does buying a phone cause you to buy a flat screen TV? Yes, I know we're in 2022, and most of us do have iPhones, Androids, and most of us do have flat screen TVs, but not everyone has a flat screen TV. So this is a correlation because there is no evidence that it is being caused to buy a flat screen when buying a iPhone or Android phone. Number 2. Since 2004, the average salary in an NFL football player has increased every year. The average weight of an NFL player has also increased yearly since 2004. After much discussion, Alonzo and Richard reached a conclusion that higher salaries cause the players to gain weight. Now, that does not happen. That is not causing somebody to gain weight if they're making more money. I wish we could all make a bunch of money and eat whatever we want, but that's not the case. So this is also a correlation because it can't prove that one thing caused the other. Number 3. Worldwide, the number of automobiles sold annually has steadily increased since 1920. Gasoline production has also steadily increased. Alonzo and Richard concluded that the increase in the number of automobiles sold caused the increase of amount of gasoline produced. Now, this one, I'm going to put a star because that one, it does make a sense that this could possibly be causation. We just need a little bit more input. Why is it possibly causation? Because buying more cars does increase gas being used. So this is a pretty good problem right there. For my ELL learners, definitely get some Google Translate so you could get the feeling of it. But I know for a lot of us, increase, I can't tell you, but we should know key terms for sure. Next page. This next page is of a lot of opinion on your own. So please be ready to write your own opinions. 7 minutes, let's see if we can rock and roll. Proving causation is challenging. The scenarios that Alonzo and Richard analyzed demonstrate that even though two quantities are correlated, this does not mean that one quantity caused the other. Exactly. This is the most misunderstood and misapplied use of statistics. Why are we doing this? Because we like to bust your brains. Causation is when one event affects the outcome of the second event. A correlation is a necessary condition for causation, but a correlation is not a sufficient one. Correlation coefficient is just there to show you how things are related, but does not show you that something does cause another thing. Let's talk about these problems. Many medical studies have tried to prove that smoking causes lung cancer. But does it? Is smoking a necessary condition for lung cancer? Why or why not? Is smoking a sufficient condition for lung cancer? Why or why not? Is there a correlation between people who smoke and people who get lung cancer? Explain. Is it true that smoking causes lung cancer? If so, how was it proven? A lot of opinions, but I will give you the first so that you can write your own statement. Is it a necessary condition? No. Because, fill out your own part. Is smoking a sufficient condition? No. Because, is there a correlation? Yes. Because you fill it out. And is it true that smoking causes lung cancer? Yes. Because all your own opinions, please, ladies and gentlemen. All your own opinions. But sir, I don't know what to write. Well, figure it out. Do some Google research. Definitely, just so I don't overextend this video, give yourself number 5 a piece to practice. Get your mind into thinking. Number 6, also give your mind to thinking. Jumping to number 7. A lot of opinions here. Consider each relationship. List 2 or more common responses that will also cause this result. So, what else would cause temperatures to increase? Oh, I'm sorry. What else would cause the number of shark attacks? So what else causes shark attacks? Give 2 or more reasons. How else can people lose 20 pounds? Come up with 2 more reasons. What else can cause people to lose weight? 2 reasons, just so you can get your mind thinking of what causes something else. OMG, we're at 12 minutes, but that's okay because we're already finished. Last part is the talk to talk. Linear regression for each set and the correlation coefficient. This is your exit ticket. Make sure you can do it. Make sure you can apply it. And we'll see you all better next time. Y'all have a great day.